Hello, ladies and gentlemen, and welcome to module number 7, lecture number 7, multiple linear regression. So if you remember last time we were talking about how a linear regression has a predictor variable and an outcome variable, and you have, a bunch of data spread like this, and we kind of want to draw a line so that the best estimate of, if your x is equal to this, you go up to here, and on the average, your y will be equal to that. Right? And so this is simple linear regression. Now we're going to talk about multiple linear regression, which is what happens if you have x1, but then you have x2, two levels of x2, or more levels of x2, and then you can have x3s, x4s. You have some of these crazy linear regressions that just get out of hand sometimes. So let's start. All right. So in most practical settings, more than one explanatory variable is likely to be associated with a response. Multiple linear regression is used to estimate the linear relationships between a response variable y and several predictors. So you remember that line formula that I gave you last time? So here you have your first predictor, your second predictor, all the way to your nth predictor, your intercept. So if all the predictors are equal to 0, then y will be equal to your intercept. Same thing. Here's the same line. There are several applications of multiple regression, estimating association between a response variable and a primary predictor of interest while adjusting for possible confounding variables, and also for constructing a model that effectively explains the observed variation in the response variable. This is probably the number one reason why we do it in biostats, and this is number 2. You've heard a lot about modeling, and so we'll talk about these. So statins are a class of drugs widely used to lower cholesterol. If followed, recent guidelines for prescribing statins will lead to a statin use in almost half of Americans. We tend to eat a lot, and we tend to eat a lot of fat. Probably should cut back on that. So anyways, nearly all men over 60 would use statins. I know. I need to go for a jog myself. So a few small studies have suggested that statins may be associated with lower cognitive ability. So what do you see here, right? You have statin is going to be given to you based on your age, and cognitive ability is also associated with your age influences that. So what happens when statins also influence cognitive ability? Then your statin becomes a confounder. Or if you want to draw this differently, then your age determines whether you take a statin, and your cognitive ability, and then your statin is influencing your cognitive ability. In that case, age becomes a confounder. Either way, we need to control for this, right? So here's the RFT score. Is there a line in there? Maybe. Yeah, maybe it goes like this. The older you get, the lower your RFT score. Here we go, user and non-user. Sorry, again, it gets cut off. Need to work on that. User and non-user, look at the median, right? Look at the spread. Some outliers over here. Okay, so then let's do a linear regression. So the coefficient, the intercept, the statin user, so the expected y of RFFT is equal to the intercept 70.71 plus or actually minus, because it's a minus right there, 10.05 multiplied by whether or not you're a user. Okay, so we have the coefficients. P is the number of predictors. P's right there. Okay, so basically just like we used to do. So now we're not only looking at RFT and statins, now we're looking at RFT and statins plus age. So now our RFT, or our expected RFT, is equal to 137.8822 plus 0.8509 minus 1.2710. This, of course, multiplied by x1, and this one by x2. Which x1 being that and x2 being that. So for every one increase in age, your RFT is coming down, and if you are on a statin user, your RFT is going to increase by that, and then your baseline RFT is this. The fact that this changed so much from the previous one, from -10 to this, tells me that it is being confounded by age. and that age helps adjust for that. And so here you see, again, the summary, the estimates. So we would call this beta 0, beta 1, beta 2. Standard error t-values. P-values are all significant because they are less than 0.05. So that's good. So the assumptions are the same as the last time. L, E, I, N. Residual plots, just like last time. We talked about this. We talked about how we need to make sure that the residuals are equally distributed. However, it's not possible to make a scatter plot of a response against several simultaneous predictors. So for each numerical, we used a modified residual plot. For each numerical predictor, plot the residuals on the y-axis and the predictors on the x-axis. Patterns, curvature, indicative of nonlinearity, constant variability, and normality of residuals can be assessed using the same methods as simple regression. Okay, so we have our summary to get the R squared. So 28% of the variability, hint for the final exam, 28% of the variability in RFFT can be explained by statin and age. What explains the rest of it? Probably other variables. Gender, there's association between gender and cholesterol, your height, your weight, your BMI, things like that, right? So remember R squared, remember the formula for that. What about categorical predictors? So statin user is a categorical predictor, right? And so I told you this. You start this as your baseline, and if you use or don't use, will vary by 10.05 score of 10.05. So if you use x1 will equal to 1 if you're a user, and will equal to 0 if you are not a user. So if you make this 0, then your baseline. But if you make it this 1, then you have to subtract 10 from the baseline. Is it associated with education? So now we're gonna have another one, right? An x3 come into the mix. And so here, categorize it as 0, 1, 2, 3. So x3 equals 1, equals 2, equals 3, or equals 4. And look at this. The higher your education, the higher your RFT score. There's some overlap. Are these significantly different than each other? We'll talk about that. So here you see RFT and education, the intercept, and then each level. Your baseline, what was your baseline? You see primary is your baseline. And so primary is going to be your intercept. Okay. So these are the means that you're seeing actually displayed in here. And so now we're saying that the baseline category represents individuals who have most completed primary school. Intercept is a sample mean of these individuals. And then an increase of 14 points is seen for lower second, and so on and so forth, right? So the higher your education, the higher your RFFT scores. And so let's do some inference. So again, the same line, we have the residuals, right? Inference is usually done about the slope parameters. So remember, your HO is that beta 1 is equal to 0. But now that we have multiple, it is beta 1 is equal to beta 2 is equal to beta 3, which are all equal to 0. In other words, when you plot them on a line, your x's, all your lines for your other x's, x1, x2, x3, etc., they're all flat, right? There's 0. There's no slope to them. So here you have it. They're not associated. Well, they are associated if the slope is somehow not totally flat. Degrees of freedom, n minus p. Remember, n is a number of cases, p is a number of predictors in the model. Another big hint for your final exam. The t statistic, your 95% confidence interval. F statistic in regression is used as an overall test to the model. So here, remember what I just showed you. Beta 1, beta 2, beta whatever is equal to 0. then you're at least one of the coefficients. We don't know which one. We'll see in the analysis, but at least one of them is not equal to 0. And so there is sufficient evidence to reject if the p-value for the f-statistic is smaller than or equal to alpha. So here we go. This is your RFFT education. Any of these greater than 0.05? Nope, they're all statistically significant. So there is a significant difference between education and RFT at all levels. So now we're going to do an ANOVA. Remember ANOVA from a couple of chapters ago? F value less than 0.05. So that means that all of them are not equal to each other. Or I'm sorry, that at least one of them is not equal to the others, and then we do the pairwise comparisons to see which ones they are. And it turns out that all of them are different to each other. All of them are less than 0.05. So now we're gonna throw statin, age, education, and CVD in there. So look at this. Whether you use our statins or not has become not statistically significant. Your education is borderline significant. Your CVD is borderline significant as well. So statin user went actually from being very significant to now not being significant anymore. It's actually the other predictors that are influencing whether or not your RFT score is going to go down. It's actually your education, your age, and whether or not you have CVD. So interactions. This is, I'm going to be honest with you, this is something that was very difficult for me to understand the first, the second, the third time that I studied it. So I don't expect you to fully understand it. Again, this is an intro course. Just know that interaction exists. Just know things like this, for your final exam. So consider a linear model that predicts total cholesterol level from age and diabetes, right? So age and diabetes. And I already showed you what the intercept is, age, diabetes. So you see the lines there, right? Pretty linear. Cholesterol versus age, diabetics and non-diabetics, right? Diabetics, non-diabetics. The older you get, the lower your cholesterol if you're a diabetic. The older you get, slightly higher cholesterol if you're a non-diabetic. Interesting, right? So now we put them in here, and there something's going on here, right? As you grow old, your diabetes status determines your total cholesterol. So we have an interaction term for the interaction between diabetes and age. It's the interaction term between diabetes status and age, and beta 3 is the coefficient of that interaction. So that coefficient is right here. Okay. So if x1 and x2 are both 0, then 0 times 0 will also make this 0. And this will be your total cholesterol, which doesn't make sense because who has a total cholesterol of 4.7? But, if somebody who is 20 years old, with no diabetes, then what is 20 times 0? 0, right? But what about somebody who is 50 years old and is diabetic? The next 3 will be 50, right? So that kind of thing is something to have in mind when you're looking at these formulas. What do they mean, right? And so for diabetics, the model equation is this, right? Diabetic, yes, your age. For non-diabetics, it's 0. That zeroes out, that zeroes out. So it's just left with that. And then the significance. So age is significant, diabetes, yes, is significant, your interaction term. So there is an interaction occurring between age and diabetes. Okay? And then finally, model selection for explanatory models. In explanatory model, the goal is to construct a model that explains the observed variation in the response variable. So there exist purely algorithm methods that screen a large set of predictors and choose a final model by optimizing a numerical criterion. We are not studying that in this course. So data exploration. So this is how we choose our models when we're doing like an actual study. We want to look at our data and see how the data are distributed. Are they skewed? You know, do they follow a Poisson distribution or a chi-square distribution, a binomial distribution? We also fit the model with the predictors. You know, you see the line, the y equals beta 0 plus beta 1 x1 and so on and so forth. We throw everything at it, and then we see how well the line fits. We want to have the model with the highest adjusted R squared. And sometimes we need to take out things from the initial one if they're not statistically significant. Okay? And then we examine this, and then assess the fit of the final model with residual plots. We look at those residual plots that I talked about last time. So just a quick study. You look in lab number 5 for more information. And that's it, guys. If you have any questions, comments, concerns, you have the discussion forum, you can reach me by email. This is lecture number 7. We'll do 8 and then 9, and then we're done.